Velocities of wave is the distance of propagations per unit time in the fixed directions of the wave. Means how much the distance travel in 1 unit of time. The 1 unit of time can be 1 second or 1 minute or 1 hours. And then is denoted or is given by the formula V equals to F lambda. V is the speed or the velocities of the wave. F is the frequency of the wave, and lambda is the wavelength. Lambda is suppose this is lambda. So lambda is the wavelength of the wave. Okay, there is a lot of calculations that related to these equations, and some of the calculations can be quite hard actually. So make sure that you remember this formula, V equal to F lambda. Factors affecting V, F, and lambda. Okay, so what will affect your frequency, and what will affect your speed, and what will affect your wavelength? Let's start with the first one. Let's start with the frequency. I would like to discuss the frequency first. Always remember, the frequency of a wave is determined by the source of the wave. It depends on how fast the source vibrates. If the source vibrates very fast, then the frequency is high. And if the source vibrates very slow, then the frequency is low. And it is not affected by the velocity and the wavelength. You cannot change the speed to change the frequency, no. And you cannot change the wavelength to change the frequency. So it's not affected by V, it's not affected by lambda. It only affected by the source of the wave. Yeah. For examples, a piano. Okay, you can use the pianos to produce sound with different frequency, like do, re, mi, fa, sol. Okay, do. So the frequency depends on the key that you strike. If you strike do, then the frequency is always do. Okay, you cannot say I strike do, but I change the speed, then it becomes re. Cannot. The frequency of a wave is always affected by the source only. Okay, by the source only. Yeah. Sometimes, okay, in exam they will give you something like this. They will give you the graph. They ask you which one is the correct graph. They give you frequency. Okay, frequency against velocity, or frequency against wavelength. They ask you to sketch the graph, or they give you the graph. They ask you which one is the correct graph. Okay. Now a lot of students, they see from the formula, the frequency is here and the V is here. So it looks like they are directly proportional, which means if the velocity increase, the frequency will increase. Okay, looks like they are directly proportional. So they will give the graph something like this, and this is not correct. Why? Because I told you just now, the frequency is not affected by the V. No matter how the V change, the frequency will not change. The frequency will only affected by the source of the wave. So therefore, the correct answer for the graph should be this. So the frequency remain unchanged, even though the velocity changed from 0 to a very high velocity. The frequency still remain unchanged. For the wavelength also is still the same. Okay, still the same. The frequency remain unchanged. Okay, so the frequency will not change if the velocity change or the wavelength change. Always remember this. Okay, so frequency always constant. The second thing that you need to know is the velocity. The velocity of a wave determined by the medium of the propagation. For example, for sound wave, the medium can be solid or liquids or gas. Okay, and sound wave travel the fastest in solid and the slowest in gas. Okay, so the medium affect the speed, but it is not affected by the frequency of the wavelength. You cannot say I increase the frequency, I increase the speed. Cannot. So the frequency cannot change the speed. Only the medium of the propagations can change the speed. For sound wave, if it travel in solid, it will be very fast. If it travel in air, it will be very slow. Okay, so that are the factors that affect. It's not the frequency. Yeah? That's is another important things that you need to know. Lastly, wavelength. Okay, so what are the factors that affect wavelength? Wavelength is affected by both of this, velocity and frequency. So it depends on the velocity, and frequency is directly proportional to the velocity but inversely proportional to the frequency. It means that if the speed is high, the wavelength is high. But if the frequency is high, then the wavelength is low. So the wavelength is affected by both of this. Frequency is affected by the source. Velocity affected by the medium. Wavelength is affected by both the velocity and the frequency. So if they ask you to plot the graph for lambda against v and lambda, so lambda against v and lambda against f. So now since lambda is directly proportional to v, so you will get a straight line that passes through the origin. And if it's inversely proportional, then it will be a graph like this. It's a curve. So this may come out, usually it's in objective questions. They give you a few graphs and then they ask you which one is correct. So for lambda against v is a straight line passes through the origin because they are directly proportional. And lambda against f is a curve like this.